Hi again, HelSec. Last last time I was actually like physically on stage, I believe was roughly 5 years ago. I've been doing a virtual thing while there was this COVID thing that people fondly remember, I guess. And 5 years ago, I gave a talk with the exact same topic, with the exact same focus area. I hope the content is a bit different after 5 years. It is basically about the tool I developed. And yeah, the HelSec was the first public presentation about the tool in general. So yeah, now both HelSec and FFUF, the tool that I'm presenting about, have reached the ripe age of preschooler. So this is probably the correct time for absolute anarchy and disobeying for both. So yeah, who am I? I probably know like a half of you already because I'm loud. And yeah, so yeah, I'm working as a head of security testing at Visma. And yeah, I've been doing like open source work. Like before Visma, I was working at the EFF, developing CertBot full time. Some of you probably have had the pain of running my code in production already, do that. Some of the other tools that I have developed, like my own projects, FFUF, that I'm presenting today. Acme DNS is another thing. And there's Confused that I developed while working at Visma. So when not on the keyboard, I'm doing parenting and or drinking craft beer and playing board games. So yeah, like big ups to Olarin Panimo because this is the real thing. Like great stuff. I'm a brewer myself as well. That hobby has been in a bit of a hiatus recently, but yeah, still planning to continue. I have been involved in TurkuSec from its inception. As with HelSec, I was also a speaker in the first TurkuSec meetup some 7 years ago or so. And now, like Juho, I gave some space to the new blood in the board this year as well. So I'm not there ruining your day anymore. And you can find me with handle Joona on the intertubes, basically everywhere. So, about FFUF. What is this thing about? Like, I'm sorry for people at the back. There's going to be like a smallish text. Maybe you can watch the stream. But yeah. So FFUF is a HTTP brute forcing tool. For those that are not familiar with it, it basically takes in a word list and blasts through all of the entries of the word list to a configured target endpoint with a lot of like different options, different places to fuzz or different places to test, basically. So you have a bunch of different things in HTTP protocol that you can actually kind of test with that. It is the main purpose is obviously to detect any anomalies in the responses, so you're able to kind of figure out where something unexpected happens, and you can dig deeper manually from there. You can also, like probably the most used use case for FFUF is still content discovery. Like I guess like 90%. It's a pretty rough estimation, obviously. 90% of the users are probably using FFUF for only that thing and don't know the other things in the tool or other abilities of it even exist. They're just doing like making the FFUF go through the directories and trying to figure out things that are not visible for the eye from the get-go. So yeah, it is all about flexibility. So the kind of a main design principle of the tool is that it is just as good or just as bad as its user. It is not doing any hand-holding. So still probably the most common issue or a bug report I receive is that, okay, I'm doing this post request to this HTTP form. It does not work. The tool is broken. No, unfortunately, you know, there's this content type header for the that you have to include for the web servers to actually yada yada yada. But yeah, it doesn't do any hand holding. Other tools basically include that header from the as it is if they see any post data and no content type header defined. But FFUF, yeah, just as good or just as bad as its user. So don't blame me. Yeah, it's designed to be a Swiss Army knife, really customizable as well. So how it all began. So as I told you, the first public presentation about FFUF was 5 years ago at first HelSec at Sanoma. Big ups Osku for organizing that thing there. And yeah, it was awesome. But at that point, FFUF was just like 2 months old, like 2 months since the first release of version 0.1. But before reaching the 0.1, obviously there has to be the initial development. And as any good like open source community citizen, as I needed a feature, this is not rocket science. Like this is not something super advanced, super technical. We're just sending HTTP requests over the wire, reading the response and doing some checks on the response. That's rocket science. So obviously there are and were tools to handle that sort of scenario from the get-go. One of the tools that I was using at the time was a tool called GoBuster. It's a great tool, by the way. Check it out. And there was something, a feature that I needed for the tool that it didn't have. And as a good open source citizen, I was set to, okay, I'll check the source code. Yeah, it seems like reasonable enough. I'm able to implement it here, so yeah, I'll just do the feature, create the feature that I need and submit that upstream so everybody else can use that as well. So there was this, then I took a look at the repository of the tool, GoBuster, and there was this huge pull request. So for the non-developers in the house, pull request is basically something it's a block of changes to the code that is there for review and for discussion before actually merging it or making it active in the active branch of the software. So there was a huge pull request, and the way that the version control works is that you cannot basically just slap a code from random points of time together and expect stuff to work. So I wanted to play nice. And I asked if they want me to base my changes on the huge code refactoring pull request that they have lying there, or the master branch. Okay, apparently I was a bit hasty in making these slides because it's missing the answer to my question. Anyway, the answer was along the lines of, I'm sorry, bro, but this pull request is a beast and it takes all of our time, so please do not submit anything at the moment. So what can you do? Had to create my own, obviously. So that was basically how FFUF got started. And yeah, it saw the first release in November 2018. The HelSec talk was 2 months later. So FFUF10, sorry. Okay. Okay, about that too. All right, so, whoa, okay, sorry. We're fiddling with the volume stuff. Okay, so what FFUF was back then? It had super simple functionalities, just, like sending in the HTTP requests, reading the responses, and trying to figure out, based on the user configuration, if there was something that it should match or filter out and such. But it basically didn't have anything fancy. It did have the functionality that I needed, and that is the kind of reason I developed it. And it was I did develop that for myself. But having worked in the open source software, open source community for a while, there's really no reason not to push it out there for everybody, right? Talk about it, so we can improve the kind of all the tooling that we need for our profession, and improve that together. Make things better, right? As a community. So yeah, I was really excited because I knew that now this is exactly how I want the tool to work. And now I'm able to actually I have the full authority over it, so I can basically see it through in a way that I feel is good. And I felt that it was the best thing ever at the moment. I was the only one though. So yeah, throughout the years, I know the GitHub stars is a really shitty way to measure anything, but this is how the GitHub stars, basically many people use the GitHub stars as a bookmark. So let's think of those as a bookmark. So these many people have bookmarked my application throughout the time. And it seems to be it almost seems like a issue with the data. So it's so linear. I don't know, but this is how it looks. So when I was giving the first talk, I'm not sure what number that may be, but somewhere around a bit under 100 GitHub stars, I would guess, during the first FFUF talk, and now we're closing to 11,000. So somebody has found it useful, I guess. So yeah, during the 5 years, is there anything new? So the tool has reached the kind of maturity multiple times here already. I have basically, this is actually something that Joakim keeps bugging me about, when I'm telling that I'm working FFUF something, and he's like, wow, you said that it was feature ready, right? Yeah. So, I kind of leave it there for a while, and then I get this bright idea that nobody else probably appreciates, and go on full steam implementing it. But that's just how I function, I guess. But yeah, there's a lot of things and a lot of bigger features implemented throughout the years for FFUF, and for me it's kind of a hands off of the project for a good while, and then hyper focus for a month or so. And yeah, we are going to go through some of the functionalities later on that are new. But yeah, the tool has been in active development. It has an active community, both using it, following it, and giving ideas about the improvements all the time. So yeah, it is very much alive. And yeah, this is actually a funny point. As I said previously, it's not rocket science. So it's the functionality of the tool. It's rather simple, right? We're just using simple plain text protocol to send stuff to the wire. reading the responses and deciding based on that how we should treat the response, right? Is it something that we should alert the user of or not? But for me, it is all about the intuitivity. It's about the user experience of the tool, like how you would think that this thing should work, right? Are you expecting some sort of a dark magic? So you just like type in your one-liner and you know the CV starts flying. Yes. Well, yes. For some intents and purposes, that's exactly how it works, though. As I said, though, the tool is just as good as or just as bad as its user, per design. So in order to have a really kind of a good Swiss Army knife of a tool, you cannot do much of the hand holding. You cannot do any of the black magic behind the scenes. Everything needs to be user controllable. Everything needs to be understandable. If the user doesn't understand something, it isn't bug reports immediately, and that takes time. So it's actually good to be like good to make it intuitive and such. The most common type of feature request that I receive for FFUF is usually something really, really specific. It is something that the user is like has their mind set on to, like they want to do this exact thing, and they want that feature to be in the tool. Unfortunately, usually implementing that sort of stuff into the tool would actually compromise other use cases of it, like doing some black magic behind the scenes. You cannot really detect the intention of the user in many cases. Yeah, you can fiddle around, like figure stuff out from the command line parameters and stuff, but you really don't know about the intent. And it is a lot of, like, especially with the current amount of features, there's a lot of like interoperability issues. Well, not issues, but interoperability things that need to be taken into account. And stacking these like a really use case specific features on top of each other would result into the complete unmaintainable fucking chaos. I love chaos though, but I don't like maintaining it. And yeah, one of the design kind of decisions I took early was to try to stay as independent as possible. So basically that means that whatever feature, whatever thing that I implement in the tool should be kind of, I should not, you know, have to rely on third-party developers of like a different dependency libraries to kind of, figure things out for me. But yeah, to have actually full control over the thing, you need to do it yourself. Golang is like a really great environment for that because the standard library actually provides you with a lot. And that is, for the longest time, that was the only dependency. Somewhere along the line, I added feature for configuration files that are using a TOML format. And that was the first. And yeah, that was the first third-party dependency because I don't want to write the parser myself. That, like, what could go wrong, right? Writing parsers is like for the uninitiated. It's the kind of it's the ugly stepchild of implementing your own crypto. Not about the cryptocurrencies, but the cryptography. So yeah, for the longest time that was the case. There are now a couple of dependencies. One of them is, I think, like doing something super stupid and simple, like I think it was for like a XDG home, like a standard for defining the home directory path or something like that. In order to do that across the different operating systems and such. Stuff like that. I think there are like a direct dependencies number is currently I guess, 3. Okay, what about this guy? So the ones that actually know the tool have probably seen that fellow somewhere. And it was also an open source contribution. This is for the people in the back that probably cannot read the small text. There was this Canadian illustrator that sent a tweet that said, "Yay! I just did my first brute force with FFUF on TryHackMe attack box. Yay! I want to design a mascot for FFUF. It would be fuzzy. Get it?" And I was like, "Whoa, yeah, that would be super cool. Author of FFUF here, in case you ever do end up doing this thing, please ping me. I'd love it." And she loved the idea, and so the FFUF mascot was born. Open source contribution. It's great stuff. Like, in order to contribute into the open source software, in order to contribute to the communities like HelSec, TurkuSec, whatever, just like contribute whatever you like, whatever is your expertise, what is your thing, and let everybody enjoy it. Okay, so what has happened during the 5 years? There's a lot. So the tool, yet again, I feel that the tool has reached feature completeness. There are a ton of things like proper rate limiting. That is actually, it is important thing on the both sides of the fence. So if you're testing something, it is really good for you to apply the rate limiting in order to not to get not to get attacked by your family by basically getting your house, your broadband IP address banned from Akamai or something like that. Nobody can watch Netflix in the house for a week. Not nice. So please use rate limiting. The server maintainers, they appreciate that as well. There are, pretty common sense defaults, how much you should bombard a endpoint with, what sort of rate you should bombard the endpoint with. The kind of fastest I have seen FFUF go is 20,000 requests per second, and that is a lot of traffic for the, both for the network maybe, but especially for the web server to actually kind of try to parse. Web server needs to do a lot of things for the requests. Try to figure out, there's a lot of things, a lot of resources that you can exhaust with reckless use of offensive security tools. But yeah, FFUF has seen a lot of different things. Many of them are in the, as I said, rate limiting, in the actual a network layer of things. But a ton of just simple quality of life improvements, interactive mode, where with the command line tools, you set your parameters on the invocation of the tool. But in this case, when you're doing a web fuzzing, web brute forcing, you don't really know beforehand what sort of stuff you want to filter out, for example. So interactive mode is something that you can start your scan, hit enter, it basically pauses the scan where you enter this interactive terminal where you can set the different parameters, and then it will kind of filter out your existing stuff from, and you just hit enter again and it continues. Stuff like that. You're able to basically modify stuff on the fly. FFUF has also gone through a couple of code restructures. At some point when developing a piece of software, you start to notice a kind of okay, so I was a bit hasty here. I didn't have this sort of functionality in my mind when implementing this thing. So I could have made it actually better to, yeah, to remove parts of the code that is unnecessarily there, or just to make things smarter. Not in the bad way smart, like IoT, not IoT smart, like bad smart. No. But yeah, there are a couple of like as complexity huge features. The scraper functionality, which basically makes FFUF a vulnerability scanner of a sort. There's a kind of one feature that I'm actually pretty proud of. It's a FFUF hash and a way to regenerate the request that was initially sent in a workload 2 months ago without saving all the requests that go out. There's payload encoding. It's another project called Pencode that I just integrated with FFUF and yeah. Raw request parsing, that is actually really beneficial, especially with web applications of today where you have like a truckload of cookies. Everybody loves cookies, but enough is enough. So you don't have to define like everything on the command line. Instead, you can just like save the raw request to a text file, pass that to FFUF, and define your keyword somewhere in that file, and FFUF will pick it up and yeah, do its thing. So yeah, there's a lot of things has been going on in the 5 years. One of the cool things is also so the way that FFUF works is it has matchers and filters. First, something in the HTTP response is matched. Let's say we want to match every response code 200, which means like OK. That is like a default HTTP response when the content is found. So we want to match everything that responds with 200, but we want to filter out everything that is 0 size, for example. So FFUF first goes through the matchers, then through the filters, and whatever passes both of them, they will be shown to the user. So one of the cool things is also time-based filter and matcher. So you're able to kind of, for example, just spray around your blind SQL injections and figure the round trip time, and if the round trip time exceeds whatever sleep, because obviously when testing for like SQL injections, you probably should not start with drop tables, right? So yeah, you're able to identify things like that. So yeah. Okay, so the first kind of recent bigger feature that I kind of want to talk about, I'm really, really, really sorry for the people at the back. The text is small, but I'm trying to verbalize a large part of it. And there's a list of URLs at the last slide where you can basically see all of these URLs and all the documentation based on those. So this feature, it's an in-flight payload encoder. The way that FFUF and many of these HTTP brute forcing tools work is that you have a word list that may have the word list may have 1 entry, it may have 100 entries, or it may have like 2 million entries. The tool will then go through all of them, and then based on the responses do the thing that I just described a couple of minutes ago. What the in-flight payload encoder does, that it basically applies a chain of encoding functions to each input from the word list. So you can, in the example, these are absolutely, completely theoretical. No real life things here, but you know, in this command example on the screen right now, what the FFUF is going to do is it's going to read each line from the word list.txt. First, URL encode it, and then base64, like create the base64 string out of that result. And you can chain these up until infinity. There's actually also a templating engine, so you can actually apply templating as a part of this thing. So you can, first apply template, then URL encode the result, then whatever. There's like 10-ish different encoders that you can use. You can do like a hashing with typical hash algorithms, stuff like that. It happens in flight, and it's fast. So yeah, this is actually something that's happened during the last year. Development that happened during the last year. Actually, I think I'm planning to go through 3 of these bigger features, and all of them happened during the last year. So yeah, the tool itself, like a pen coder, that is also a standalone CLI tool. You will see a kind of a link to the repo later, in the last slide of the talk. But yeah, the tool can be used both as a standalone tool or as a FFUF integrated feature. So the next thing is the FFUF hash and the request history, and how to actually kind of replay so I'm actually going to explain a bit of the rationale, like why this feature exists. So in order to do let's say we want to figure out some blind XSSs or stuff like that, blind SSRFs. That means that, and in a way, they actually, there's also a factor of, some of these inputs that you kind of send towards a server or towards an application, they may be kind of there in the kind of in the machine for minutes, seconds, hours, days, weeks, maybe even months. It may be somewhere along the line when the data has gone through, let's say, a log file parser and then a user interface that interprets the results from that. It may trigger only then. So how can we match a request to that? So many of you that are familiar with offensive security testing tools probably know how Burp works, and Burp has the feature called Burp Collaborator. This is a bit of a same sort of a thing, but yeah, you can actually correlate the exact payload that was used to generate that response as well. So how to make that happen without saving every, as I said, a FFUF job can be basically a couple of million payloads sent towards the server. You do that daily, and then after 4 months, something triggers, and you see a callback from something. You probably don't want to save all of these millions, or in this case, hundreds of millions of requests, raw requests, to anywhere on the file system, especially in the case of CLI tools. That would probably be a pretty nasty surprise for the user, because users probably don't expect command line tools to randomly, especially command line tools that are not focused around archiving stuff. That sort of tools, like taking up gigabytes or tens or hundreds of gigabytes of space. So instead, what FFUF does, it actually saves the parameters you use for each run to a file on your file system, kind of a history file of a sort. And half of the FFUF hash, which is a keyword in FFUF, just like fuzz is the default keyword for the word list entry input spot. FFUF hash is a keyword that inserts a hash that the first part of it is from is a reference to the history where you can find the exact parameters used for the FFUF execution. The second part of that is the position. So it means, position in this case means that which word list entry or which kind of job position was the one that kind of triggered. So with equipped with that information, we're actually able to kind of regenerate that the exact request that got sent in that exact time that generated that or resulted into that kind of a callback a couple of months later from the exotic software server somewhere. And this way, we're actually able to circumvent storing shitloads of data onto the machine without the user's knowledge, basically. And yeah, we're able to basically reach roughly the same end results. So the third thing, scraper. How to create a vulnerability scanner out of FFUF. We all love regexes, right? Give a yay for regexes. Yay! Yay! Yeah. Yay for Zalgo as well. Yeah. So you can basically, with this functionality, you can create these JSON files into a specified directory on your machine that have these rules. You're basically able to use regexes for some, like let's say, a specific software version that has this specific fingerprint has a critical vulnerability. But then, okay, you have this rule that would match that specific fingerprint, but what if you actually encounter that thing while doing something completely different? So you're doing horizontal scan, like targeting a lot of different environments, different endpoints, different web applications, and you're looking for something completely different. So you're kind of, you don't expect to find that sort of a thing. And because of that, your options for the FFUF are such that it would filter out all the 200 requests, for example. So the tool still will receive the response. And it will still process the response, even though your currently active configuration says that it should ignore these whatevers. So this functionality and these templates actually have a variable that you can set that matches regardless. So it basically, if you filter everything out, but you have set the kind of a variable. The variable is only matched. That takes a Boolean value. And if you set that to false, it will always let you know when you have found something that you know is really bad, even if you're not looking for it. If FFUF sees that anywhere, it will let you know. So the meme here, it's about parsing HTML with the regexes. It's a really bad idea in general. And because of that, so the scraper functionality, in addition of, let's say, looking for regex fingerprints somewhere, it can be really well used for, I have this list of 200,000 websites that I want to gather the title of. Just to kind of, for some reason, I don't know. So you can use the the syntax that is for all the people that are have been doing some sort of front-end development. There's this sort of a syntax where you can basically define HTML structure in a non-regex way that is actually human readable. And you can, like, if you're looking at it later on, you can you can still figure out why the fuck did you write that line for. You can also define if you want to look for these matches from only the body, the headers, or everything. Obviously, doing HTML parsing or HTML matching for headers is probably a moot, but yeah. And yeah, these are things, examples of stuff that has happened for FUF for the last 5 years. The pronunciation of FFUF or FUF or it is something that is like everybody. Like first question, if I'm interviewed anywhere, is that how do you pronounce that shit? I don't know. You figure out. But yeah, like all in all, this was the presentation of FFUF like 5 years later, and this is the results. I said Swiss Army knife, right? The comments in this Amazon entry says that 5 stars, surprising results. I tried to file my nails, but in the process I accidentally fixed a small engine that was nearby, which was nice. And this is kind of yeah, how do you create a simple web fuzzer? So thanks. All right, so I'm taking any questions if there's any. Yes? Do we have a mic for the audience? Yes? Wait, there's going to be a mic.
Seems to work. Oh, a bit too loud. Always the same guy with the questions.
About cross-site request forgery tokens. So many forms mandated by the framework, they give you a hidden field with a secret number, and that secret number allows you to submit the form exactly once.
Yes.
Is FUF supporting or planning to support this functionality, or is there, if it's out of scope, is there another open source command line tool that would work nicely for fuzzing forms with cross-site request forgery tokens?
I'm not aware if there is a tool that is actually doing that well. You know, it is not it's not a simple thing to do. And I returned to this slide because there is actually you can actually see here there's a key called action that is currently not used for anything. The only value that I use in all of the example is action is output. This is actually in place for exactly for the reason of your question. So the kind of long-term plan is to have a functionality, as I said, feature complete. So have a functionality that actually picks up the, for example, using the regex rule or the HTML matching, we'll pick the CSRF token and kind of pass it to a rerun of like something else. So it would be a kind of pre-flight, not a pre-flight request as defined in the standard, but a pre-flight request for FFUF for picking out the CSRF token. So yes, the answer to your question, I'm not aware of any tool that is able to do that well today, except Burke is like doing it decently. Other questions? Yes?
Okay, non-technical one.
Yes.
Are you aware of any, let's say, commercial product or maybe non-commercial product that uses FFUF? Or let's say, I was thinking maybe something like Shodan, they probably need some technology like this.
Could be. I am aware of a couple that are using it, inside of the product itself. And there's a lot of like open source tools and products as well that are using it internally. And also it's used by many commercial, companies, obviously, in like manual testing as well. And the follow-up question is probably like why I'm how much money do I have because of this? I actually was planning to have that on a slide. I'm getting sponsorships to GitHub, and the current projection for this month is $32. So that's now you know how I can afford my lavish lifestyle of craft beer and board games. Other questions?
Way in the back. Okay, let me get there.
But yes, just to add to that, that is totally fine, and that is by intention. The license is MIT, which allows you to do anything with the code, with the tool. Yeah. Okay.
If I got it right, you basically use regex to like parse the HTML, but what if the one thing you're searching is like deep? I mean, the depth of the item you're looking for is like the depth of the item you're looking for in the DOM is different. It depends on like the exact page, so it can maybe move, but you always know it's the deepest level of the DOM. So how do you do that with regex? Basically, if you have a recursive structure, but you don't know how deep you have to recurse to find that item you only know like the property name or something. How do you do that with only regex? As far as I know, that's something you actually have to, you can't really do with like a defined finite state automaton. So I'm actually curious how you fix that.
I'm sorry, but unfortunately the ambient noise actually was blocking most of the question. I know your voice though. Welcome, Peter. So it was about the recursion. How do I know? But those were the kind of things that I was able to pick up, unfortunately. But I'll answer your question happily like afterwards. Unfortunately, I can't. Yeah. Anything else?
Any
I guess
other
not.
questions?
Okay, perfect. Thank you.